Alrighty, so today is April 15th, Wednesday, and we are on week 11 of this class. I think we only have 18 weeks, so you guys only have a few more weeks left before the end. So hang in there. If you look at the chat room, you can see that I also included the class worksheet for today. So if you haven't done so already, print it out or have it in front of you on the computer. So at this point, I'm going to go ahead and go over the announcements. Oops. Alrighty. So we'll expect to go to about 12:30 today. Before we start, actually, I would like to just give us a chance to check in. And since there's not too many people right now, I think I can go through and just ask everyone like we did on Monday. So in one word, describe your week so far. And there's a cute little hamster that says, how's it going? So if you guys can unmute yourself and just think of just one word, and I'll just go through and call on people. Go ahead and unmute yourself. So Garrett, we'll start with you. One word, describe your week so far.
Sleepy.
I'm sorry, what did you say?
Sleepy.
Sleepy. Good morning, sleepyhead. Paul, welcome aboard. What's one word that would describe your week so far?
Hey, good morning. I guess productive.
What is it?
Productive.
Productive, good.
Yeah.
That's a rare word for people to say nowadays. So that's
right. Well, it started at the beginning of the week. When our
good.
class started.
Nice. Kaela, welcome aboard. Describe your week
Hello.
so far.
My week has been long, like every other week.
Oh, long week. Okay.
Yeah,
What day is today, right?
I know.
Anthony.
Busy, I guess. I don't know.
Busy. Ruby.
I've had a good week.
Sophia.
Kind of stressful.
Stressful. Ronaldo.
It's a long week.
Long week as well. Okay. Victor.
I'd say sleepy.
Sleepy as well.
Yeah.
You're in the same boat as Garrett then. Victor.
Yes.
Describe your weird. I'm sorry. What did you say?
Oh, I said sleepy already.
Oh, sleepy. Okay. Stefanie.
Tired.
Tired. Victor. Victor, we can't hear you.
Oh, is my mic not working?
Oh, now it is. Go ahead.
Oh. Sleepy.
Sleepy as well. What time is it? 10 o'clock? I know. My wake up time is like 9 o'clock nowadays, and normally I wake up at 6, but everything's adjusted, right? Stefanie.
Oh, I just went already.
Oh, okay. I don't know why I went this way. Melissa.
Stressful?
Stressful?
Yeah.
Jessica?
I'd say it's going good, but it's just really busy. Just
Okay.
catching up on everything and whatnot.
Mm.
Good.
Ashley?
It's been pretty uneventful.
Uneventful. Okay. And Alexis?
It's been okay. It's been a pretty good week.
Cool. And Paloma, you just hopped on. Describe your week in one word. I see you're trying to connect to audio. Paloma, can you hear us?
Yes, now I can.
Okay. What's that one word for you?
I'm sorry?
What is one word to describe your week so far?
Drastic.
Drastic. Wow. Okay. Sounds drastic. How about you, Jaspreet?
I would say boring.
Boring.
Yeah.
Awesome. Did I miss anyone? Did I get everyone? Okay. Well, thank you for sharing your word in 1 week. I know it's hard to share just in one word. I mean, sounds like we're all coming from different spectrums, from having it be boring or sleepy to stressful and busy and good and a lot of different things. So we're all here. So just welcome aboard and thank you for joining me this morning amidst your week. Today's announcements. After the announcements, I'll ask if you guys have any questions on anything. So if you have any questions on any work, especially things that will be due tomorrow on radicals, please let me know during this session and then I'll answer them. We're gonna go over a new lecture on quadratics. So again, the worksheet is on the chat room, but I also emailed it out to you guys on Canvas. We'll have a 10-minute break. We'll have group 5 present, and I did receive both groups PowerPoint, so be ready to present. There was Stefanie, Sophia, Ruby, and I'm not sure who else is in those groups. If we have time, we're gonna do the student spotlights, if we have time. And then we'll continue the lecture and end around 12:30. Some homework to expect is, again, the radicals. Part B is due tomorrow at midnight. Tomorrow as well is the online quiz, and it's all day, open all the way until midnight. So again, you have unlimited tries, but every time you try it, you're gonna have to do the whole quiz, not just the retake, or not just the missed problems. It's the whole quiz. So, but you have unlimited tries the whole day. And then the quadratics, what we'll be covering today, part A. So depending on how far we get on it, that will be due on Sunday by midnight. And I just do want to make a note of something. I've been talking to other teachers, and one of the problems that we've been having with doing an online class, which was expected, but it's also unfortunate, is that there's been a lot of cheating that's been happening on quizzes and exams. So a lot of teachers are cracking down and looking and comparing at homework versus exam grades. Say someone's getting a D on homework, but suddenly they have 100% on the exam. I would say that is pretty fishy. So a lot of people, a lot of teachers are cracking down on that, and it's been a serious issue with going online. And ideally, we wouldn't be doing online testing because of that very reason. So that being said, I just want to, one, remind you guys that this is the session. To please, can you guys mute yourself? To just please make sure that you guys have integrity in doing this work. For some of you guys might be going to another math class or science class where you will need to know this material, and if you don't learn it now, it'll catch up on you later. And the other part is, please don't take advantage of the kindness of your instructors, right? Allowing you guys to have all day to do it or do retakes and everything like that. It is an act of kindness. I mean, we could do a lot of things where we mandate that you go on video and take the test in front of the video where we could see you guys. We can put things on the computer, this and that. I haven't gone to that extent so far because I rather choose to trust people until I find reasons not to trust. So please don't ruin it for others or for yourself if you feel tempted to cheat. And I think the reasons why people cheat is not because they're bad people, but I think because they're stressed or they're desperate. So I really don't want you guys to get to the point of stress or desperation. And the best way of doing that is to stay on task with your homework, use the quizzes as a learning opportunity. And then the exams, that's when I really expect that you guys aren't working with other people, that you guys are working on it on your own. And that's why I'm expecting you guys to send in your work as well. But I know there's different ways of cheating around that if someone really wanted to. So down to it, have integrity for yourself mostly, and whatever, yeah. Have integrity in the small things, and that'll lead to having integrity in the big things as well. So I'll stop with that.
Can I chime in?
Yeah, go ahead, Garrett.
On a more brighter note, away from cheating, talking, if you guys remember in the beginning of the year, we had someone come in and they were talking about easy points. These the quizzes are easy points. Take that quiz until you get 100%. Not only will you get all the points, you'll have enough practice to help you for the exam later.
Really good point. Thank you, Garrett, for mentioning that. Continual homework, student spotlights, keep sending them in. I've been getting several of them, so thank you. DLAs, yes, have, by the end of the semester, you have to finish 5 of them. So whenever you do it, it's based on your timing. I have timelines that I give you guys, but I'm flexible on that schedule. Just make sure you get 5 done before the end of the semester. And the timelines are basically there just to keep you on track so you don't get stressed or have to procrastinate. Next week, we have a group presentation for group 6. Let me know if it's Monday or Wednesday. We'll continue to have Zoom sessions on Monday and Wednesday. I forgot to write this down, but Monday, it'll be at 1 p.m. and Wednesday, it'll be at 10:10 p.m. So, or a.m., not p.m. And then I'll give you guys announcements about quizzes or exams next week when I kind of figure out where we're at with the class. Garrett's tutoring hours are still available, so please utilize him. And my YouTube channel is up. I've actually organized my YouTube channel so it's by topics. So if you're wondering about radicals, there's actually a playlist just on radicals, so you don't have to scroll through all the videos looking for the topics that you guys want. All right, at this point, does anyone have any questions on anything I spoke about or anything on the material?
If I drop the class, will it affect my financial aid or my GPA?
That's a great question, Abraham. That is something that you'll need to talk to your counselor about. Yeah, because I don't know what your situation is. I think you need to be a full-time student, and I think that's 12 units to get financial aid. But check with your counselor because I don't know how precise that is.
Okay.
But your academic counselor should be available for you during this time.
Okay, thank you.
Mm-hmm. Any other questions? Any comments, thoughts, or any questions on the material?
I actually do have a question. It's a little off topic, but I wanted to know if you got my student spotlight, only because sometimes my student spotlight and my group presentation for today, because sometimes when I send it through the Canvas email, it doesn't always go through.
If you sent it to my email, it's a hit or miss. So if you can, Kaela, send it to my Facebook messaging or send it on Canvas.
Okay, I sent it on Canvas.
Oh, you did? Okay, if it's on Canvas, then I should have it. Then I'll look
Okay.
it up later. And if you have time, I'll have you present today, Kaela.
Okay, thank you.
Mm-hmm.
Hey, I have a question.
Yeah, Paul.
You said today's worksheet that we need to have up, is that for 8B or is that for 9A?
It depends on which class you're in.
Is it for quadratics?
Yeah.
Okay, I'm looking in the files folder on our Canvas. I'm not seeing it.
Oh, I actually didn't put it on Canvas. I emailed it to you guys on the Canvas inbox. I also put it on a chat room right here too.
Okay.
Got it?
Yes, I got it. Thank you.
Okay, great.
Professor, I actually had a question on the radicals because I was kind of struggling on my homework.
Sure.
It's question 16 on the packet. I don't know if you have it. I can read it out for you if you'd like.
Sure, can you read it out for me?
Yeah, so it's going to be radical -40 over radical -2. And this is a 2-part question. Can you do both or
if you need it on both, I could do both.
Yeah, if you could. The second one's going to be radical 10 times radical -2.
Okay. Radical 10 times radical -2. Okay, great. So let me go ahead. I'm going to switch camera modes. Let me find my phone. Sorry, I have a case on my phone that I need to take out real quick. Forgot to take out the case. We're
I
okay.
like your little setup you got there with the like cage.
Oh, I know. Isn't this ghetto? Look at that.
That's awesome.
I found it on someone sent me an email with it, and sorry, this is so shaky. I'm trying to take off the case off my phone so I could put it on here.
Nice pajamas.
Oh, I know, it's nice on top and pajamas on bottom.
Don't worry, I'm still laying in bed right now, so.
All right. I love pajamas. All right. Can you guys all see that?
Yeah, I can see it.
Yeah, that works.
Sorry, all right. So here you go. So here in this problem, we have division and multiplication. So actually, let me just double check something real quick before. All right, so with the part A, with division, we can basically, one of the rules of radicals is if you have square root of A over square root of B, you can write this as one radical. So you have a square root over square root, you can write it as one radical. So that's the same story with this here. So here, I could write this as one radical. I have negative 40 over negative 2. And once I have that, I can simplify the inside before I figure out the radical. So here, negative 40 divided by negative 2 will give me positive 20. So once I have it as a positive 20, I can simplify that. And here, positive 20, I can rewrite this as square root of 4 times square root of 5. Oops, and square root of 4 times square root of 5, square root of 4 becomes 2 rad 5.
Oh, okay.
Is that okay?
Yeah, I got 20. I didn't know what to do with that afterwards. So now I know what to do with it. Okay.
Right, you always want to simplify the radical. Great question. All right, and then the second part B. So in this problem here, one of the rules that I also want to mention about when you multiply two radicals, you can also combine them as one radical, which would be the square root of A times B. So you can put all underneath one radical. Just like with division, you can put it underneath one radical. If it's a radical on top and bottom or side to side, you can put it as one. So here in this problem, I'm going to combine it to 10 times negative 2. Well, 10 times negative 2 will give me negative 20. And then that's when I say, uh-oh, a negative. So we know that we can't do this with real numbers. You can't have a negative 20. So here, I'm going to change this to square root of 20 times square root of negative 1. I split the real versus the imaginary. So here, square root of 20, we realize from earlier is 2 root 5. And the square root of negative 1 is the imaginary part, which is I. Because the definition of I is square root of negative 1. So as a result, the answer, so how you write it is you always put things outside the radical together. So the I is outside the radical, so I write it as 2I square root of 5. And that becomes your final answer.
Thank you. I appreciate that.
Great.
It makes sense now.
Okay, good question. Any other questions?
Yes, I had a question on the homework.
Okay.
It's adding and subtracting complex numbers.
Okay.
It is parentheses negative 1 plus I minus parentheses negative 3 plus 4I.
Like this?
Yes.
Okay, so -1 plus I minus -3 plus 4I. Can you guys see the entire sheet on your camera?
Yeah.
Okay.
Okay, great. So here, this is, the main thing is you want to subtract the two polynomials. You have this minus this. So whenever you have a minus sign, you always want to distribute it first. So I'm going to distribute the minus sign to get rid of the parentheses. So I have -1 plus I. I distribute the negatives, I get +3 minus 4I. Is that okay so far?
Okay, so you said to take out the variable, or I'm sorry, to subtract the two.
Oh, I just got rid of the parentheses, and to get rid of the parentheses, we distribute.
Oh, okay. Okay.
Yeah, distribute the negative sign. And therefore get rid of parentheses. So I got rid of the parentheses first by distributing the negative sign through. So this becomes +3 and minus 4I. Is that okay?
Yes.
All right. And then next, we're going to combine like terms or like animals, right? So the ones that are same is -1 and 3. Those are numbers, real numbers. So I get +2. And then I have the imaginary part. So I minus 4I, you treat it like variables. So kind of like a 1 minus 4 is -3I. And you always want to write your answer where the real part is first and then the imaginary part is second.
Oh, okay. Because the explanation kind of confused me, but thank you. That actually makes it way easier.
Okay, good question. Any other questions?
Yes, sorry. So in multiplication, so with the I, we never include it. It's pretty much like a variable. We never turned it into a negative at all, like a -1, because that's what it represents.
Yeah.
So I'm sorry, can you repeat that?
So -1 equals radical negative, I equals radical -1.
Yes.
So in multiplication and in addition and subtraction, we never convert it to -1 unless necessary.
Oh.
Or is it just addition where we never do that because it's just a variable at that point?
Great question. Yeah, we never change it back to square root of -1. The thing is, square root of -1 is, you can't really ever have that. So if anything, if we have it as this, we want to convert it to that. But we don't go the opposite direction. So
Okay.
I doesn't change that. So I would replace I with square root of -1.
Okay.
I want to chime in and also say the only time we do change it is when we have I squared, because that becomes a real number, -1.
Okay.
Right.
Okay.
So when we are multiplying and you get an I squared, that's when you're going to change it to -1. But in addition and subtraction, right, we're not multiplying, so we can't get a squared. So it'll always just stay as an I.
Okay.
But in multiplying, we will get an I squared and change it.
Mm-hmm. Okay.
Right.
Thank you.
Good clarification, Garrett. Yeah. So the I never changes square root of -1, but I squared will change to -1 because you want your answer to have real numbers here. Good point. And in multiplication, will you end up with an I squared that you change it to -1? All right, any other questions? These are great questions.
Professor, can you do another homework problem?
Yep, go ahead.
Also radical simplifying a power of I. That one is a little bit more confusing because when it's an odd number, that's where I get confused.
Okay, go ahead and tell me what the problem is.
So it says simplify the complex number I 59th power. I don't know how to say that. I to the 59th power.
Mm-hmm.
And they simplify the complex number as much as possible.
Great. So that's a great question. I to the 59th power. So I actually did not lecture on this, and I'm glad someone asked me. So one of the things that we're going to notice about I is this. We know that I is square root of -1, right? So I is just I. Now, so I'm going to start creating this cycle because I'm going to show you guys this pattern that happens with I. So I squared, what is I squared? What is I squared equal to? Anyone?
-1, you said.
Yeah, -1 by definition, right? So I squared is -1. So I cubed, so remember, notice we wanted to find what I59 is. So I'm just going to show you this pattern. I cubed can be rewritten. Notice I cubed can be rewritten as I times I squared. Do you guys agree with that?
And we'll be able to find the definitions out in the homework, correct?
The definitions of these?
Yes.
Yeah, so these are by definition. Everything else I'm going to do now is I'm going to derive it from the two definitions.
Okay.
So I cubed is equal to I times I squared. If you think of cube, it has to be a 1 and a 2. If you multiply them, you get 3. You guys okay with that?
Yes.
So this is equal to I, and we know I squared is -1. So instead of putting I squared, I put -1. What's I times -1?
Negative I square?
Negative I.
Negative I. Yeah.
Just negative I. So here, in the end, I get that I cubed is equal to negative I. Is everyone okay with that?
Yes.
Now, I to the 4th. How can you rewrite I to the 4th using what's here? How can you write it as a product of two different things?
2 times negative. I'm sorry. 2 square. No, so it'd be
I squared.
I squared times I squared.
Great. So I squared times I squared will give me I 4th. Well, I squared. What is I squared?
It is -1.
Good. So I squared is -1 times another -1, and -1 times a -1 is just a
Positive.
+1. So I to the 4th, we find out, is actually equal to 1. And you might be wondering, like, oh my gosh, am I going to have to do this 59 times, right? But the reason, and the answer is no, you're not going to do this 59 times. What you're going to notice is that there's a pattern. Now when I go to I to the 5th, so I to the 5th, what is it a product of? I to the 5th is what times what?
It's a negative, so it's going to equal to a negative I.
Try again. So I to the 5th is going to be I to what power times I to the what power?
I to the 4th power to I.
Okay, I to the 4th times I to the 1st. You guys okay with that? Or you could put I to the 3rd times I to the 2nd. Anything that adds up to 5, right? The rules of exponents. Well, we know that I to the 4th is 1. And we know I is just I. What's 1 times I?
I.
Just I. So now we find out that I to the 5th is equal to I. Well, there it is. I to the 5th is equal to I. And then you're going to find out that I to the 6th, I'm going to go a little bit faster now because hopefully you guys will get the idea. So I to the 6th, I'm going to rewrite that as I to the 4th times I to the 2nd, right? 4 plus 2 will give me 6. Well, what's I to the 4th? I to the 4th is 1. What's I to the 2nd? -1. What's 1 times -1? Just a -1. So what do you know? I to the 6th is equal to -1. So what we're going to see, if we had more time, I would keep doing this. I would find I to the 7th, and I'm going to find out that I to the 7th is equal to -I. And I'm going to find out that I to the 8th is equal to 1. And then I to the 9th is equal to I to the 10th is equal to I squared, yada, yada, et cetera, et cetera. So you're going to notice that the answers for i's to whatever power repeats itself in a cycle of 4. So I to the 1st, I to the 2nd. So I to the 1st is going to be I to the 2nd is going to be -1. I to the 3rd is -I to the 4th is 1. I to the 5th, I to the 6th, 7, 8, 9, 10, 11, 12, etc. So if we have I to the 59, one of the things you could do is just go 1, 2, 3, 4, 5, 6, 7, 8, all the way till you get to 59 and see where you land, right? But that's kind of, that's the long way of doing it. Instead of, if I was teaching my young kids, I would have them just go over, do this 59 times, or go over to wherever you find the 59th spot, and then you'll get your answer. But we're not going to do that because we realize because it repeats by 4, I'm going to do 59 divided by 4. Anyone know what 59 divided by 4 is? Not 10. Okay, it's 14 remainder 3 by doing long division. Yeah, it's 14 remainder 3. So what that means is that I'm going to go through this 14 times. So I'm going to go through this round 14 times. So when at the 14th time, I end up with here, and then remainder of 3. So that means I'm going to take 3 extra steps. 1, 2, 3. So I to the 59 is going to equal to negative I. So again, the shortcut is that you take the exponent, you divide it by 4, and you'll get an answer and with a remainder, or if there is a remainder. And wherever it lands, so here's the whole number 14. That means that you just went through this 14 times, but remainder 3 means that you took 3 more steps. 1, 2, 3. So for example, let's give I to the 136. Right? We're not going to go through, we're not going to take 136 steps. We're going to do it the easy way, where we say, what's 136 divided by 4? So I'm going to do long division to figure that out, or you could do it in your calculator. So I get 34. So that means, and there's no remainder, right? That means that I went through this loop 34 times. So I go through this loop 34 times, and then since there's no remainder, I landed on the last spot, which is 1. So therefore, I to the 136 is just 1.
Professor,
Go ahead.
can I see the I to the 4th?
Sure.
Oh, thank you.
If I ask you I to the 137, we know 137 divided by 4 is going to be 34 remainder 1. So that means that I'm going to go through this 34 times, and then I'm going to take 1 extra step, so I land at I. Does that make sense, you guys?
Yes, thank you for the chart. That actually makes it way more easier to figure it out.
Then a little side note.
Go ahead.
So this is something called modular arithmetic. It's the same thing you do with a clock. So like using military time, if I tell you 1500 hours, right, you're like, oh, well, if I go to 12, I still have 3 more to go. So the remainder is 3. That means it's 3 o'clock. So it's the same kind of thing when you're doing like military time. And it's called clock arithmetic or modular arithmetic.
Thank you.
Right.
Awkward.
Right. I'm glad you brought that up, Garrett, how this relates with even time, right? We have a 12 o'clock time, but if you say 15 o'clock.
And modular arithmetic is what keeps all of your passwords safe. So have a lot of appreciation for it. This is how we encode information, is with modular arithmetic. Not like this, but it's a lot more complicated.
Right.
Thank you.
Okay, I'm glad you asked that. Was that Paloma?
Yes.
Right. Any other questions?
Yay.
Now is the time to ask. All right. Without further ado then, go ahead and stop this. Oops. All right, without further ado, we're going to go ahead and go into our quadratic sheet. Are you guys able to see the sheet on my, I keep clicking it, but it's not popping up for some reason. Oh, here it is. All right, so here is the new chapter. Notice we have 19 topics. I'm gonna go through as many as I can. However, what I can't cover, we'll reserve that for Monday, but I'll go through as much as we can. All right. Sorry, I just need to grab a few paper. All right, so quadratics. So we've talked about quadratics before in terms of solving it. So when we talk about quadratics, remember that when we talk about lines, when we talk about linear equations, notice we have like x plus 4y is equal to 2 or something. Notice that the highest exponent is 1, right? Highest exponent is 1. And when the highest exponent is 1, we know that when we draw a picture of it, the picture of it is that it's going to look like a line. And we spent like 3 or 4 weeks just talking about how do you solve a linear equation and how do you graph it. And we had steps to do that. So now, when we talk about quadratic equations, the highest exponent is 2. So for sorry, let me just pull up my sheet here. So for an example, when you look at your worksheet, you're going to see things that says 9x squared plus 5x is equal to 1 or something like that. Here, the highest exponent is 1. So when the highest exponent, the highest exponent is 2. So when the highest exponent is 2, we solve it a totally different way from linear equations. And the way that we've solved it in the past is to factor, right? And what we did when we did factoring is that we set the equation equal to 0, we factor, we use the zero product property. So those are the 3 steps to solve a quadratic equation in the past. And then, so in this chapter, we're going to learn other methods to solve quadratic equations when factoring doesn't work. Because the truth is, not all equations can be factored.
I apologize. What is underneath factor? Is it Z?
Oh, ZPP, the zero product property.
Oh, thank
you. Mm-hmm. Good question. So we're going to learn 3 different methods. The first method is going to be called the square square root property. And I just call it SRP. We're going to use the square root property to solve for a quadratic equation. The second one is called completing the square. Completing the square. And I call it CTS, again, just acronyms. And then the last one is going to be the quadratic formula, which maybe some of you guys remember from high school. So there's actually a formula to this. And of course, the normal one that we already know is how to factor, right? So we already know how to factor to solve a quadratic equation, but if factoring doesn't work, we could use any of these other methods to solve for a quadratic. So let's go ahead and get started on the first property. Oops. So square root property. And again, one of the things I love about mathematics is that the name of it describes what it does. So here in, say, question number 1 on your worksheet, it says y squared is equal to 16. So you notice that the highest exponent is 2. And what you could do is, if you think of the square, if the highest proper exponent is 2, what you could do, if you want to go the factoring method, if you set this equal to 0, you subtract the 16 to one side, you set equal to 0. Notice that this is a difference of 2 squares. It's a difference of 2 squares, so the formula for difference of 2 squares is a plus b times a minus b. And then when you solve it, does anyone have any questions with difference of 2 squares by any chance? I know it's been a while since we've seen this. And then I'm going to use a zero product property where I set each factor equal to 0. And therefore, I get y is equal to -4, and then y is equal to +4. And that is the correct answer for this. However, if we want to use the square root property, it's going to be a lot faster. So here with the square root property, and I'll write it in another color here. With the square root property, so I'm going to or use SRP. And what the square root property says is if I have y squared is equal to 16, I'm going to square root both sides. So now that we know about radicals, we can apply radicals. So I'm going to square root both sides. So square root and square root. So if you square root both sides, y squared, what's the square root of y squared?
Y.
Yep, just y. The square root of y squared is just y. Is equal to, what's the square root of 16?
4.
4, right? Because 4 times 4 is 16. But notice when we did the difference of 2 squares, the answer is -4 and 4. So whenever we use the square root property, because we need to make sure that we include the negative, whenever we take the square root of something, we have to put plus or minus. Plus or minus square root of 16. That's an arrow. So we have to put square root of plus or minus square root of 16. So when I have 4, my answer is going to be plus or minus square root of 4, which means on ALEKS, so on a normal like math exam, you could just write it like that and that would be your answer. But on ALEKS, they don't let you put plus or minus. So on ALEKS, you're going to have to write y is equal to 4 and y is equal to -4 as an answer. So here, let me talk about the square root method then. The square root method, or the square root property, or method, square root property, square root method says that when you have, let's say, y is equal to square root of I'm sorry. If I have y squared is equal to a, then I could square root both sides. And when I square root both sides, I get y is equal to plus or minus the square root of a. And that's what the square root method is. You square both sides, you square root both sides, and when you square root both sides, you get y is equal to plus or minus square root of a. And make sure you have a plus or minus. So let me give you a chance now to go ahead and try number 2. And for those of you guys that might not have it in front of you, example 2 is x squared is equal to 18. So go ahead and try the square root method, and I'll give you guys a few minutes to do that. All right, so I'm going to call on a few people to help me answer this question. How about Ronaldo? Are you there?
Yeah, I'm here.
Okay, what did you do? Go ahead and walk me through what you did.
So I square rooted x squared and 18,
Okay, so you square root of x squared and 18.
which gets rid of x, which equals to x equals to square root of 18.
Mm-hmm.
So I don't know if you stop there or you continue though.
Can anyone help Ronaldo out? Do we stop or do we continue?
I think you can continue. I was a little bit confused about it first because it's not a perfect square, but I think you can continue it. I don't know if what I did was right, but I got x is equal to square root of 2 times 9, because 2 times 9 is 18, and then I simplified that more and it's x equals 3 square root 2. I don't know if that makes sense or if that's right.
Yeah, that's what I did as well. I was not sure.
Right, good. Right, so we always want to simplify our radical. It's not a perfect square, but like Paloma did, she rewrote it, and that's why we had the previous chapter, right? That's why the previous chapter is so important, because now we know how to simplify radicals. Okay, you guys all agree with that answer?
Yes.
Yes.
I have a question. Do you use the plus or minus?
Exactly. Thank you,
Okay.
Paul.
All
So
right,
you
thanks.
always want to have plus or minus. So the answer is actually, when you write it in Alex, it's going to be positive 3 root 2 and negative 3 root 2. Good. So I'm glad you remember the plus or minus. One of the things to note is when you have x squared, that means if the highest exponent is 2, that means you're going to have 2 answers. A linear equation, the highest exponent is 1, so that's why you have 1 answer. If the highest exponent is 3, you'll get 3 answers. So with quadratics in general, most of the time you'll have 2 answers. All right, nice work on that. Now let's go ahead and look at question number 3. So let's make it a little bit harder. So in question number 3 here, I have x minus 7 quantity squared minus 50 is equal to 0. So this looks kind of scary because we're like, what? How do we use the square root method on this? Well, notice that, oops, sorry. In the square root method property, if I want it to start off as a quantity squared is equal to a number. A quantity squared is equal to a number. So in this problem here, I see a quantity being squared. So I'm gonna, to apply the square root property, I want that quantity squared to be sitting by itself, and I want it to be equal to a number. So this negative 50, I'm gonna add to the other side. So I get x minus 7 squared is equal to 50. Is everyone okay with that? All right, so now that it's a quantity being squared is equal to a number, right? And I should say A is a number. A quantity squared equal to number, what I do after that is I square root both sides. So here, if I have a quantity squared equal to a number, I'm gonna square root both sides now. And when I square root both sides, x minus 7, if I squared that and then I take the square root of that, what does this become?
X minus 7.
Right, just x minus 7. It just becomes the radicand itself, right? Because of that rule that we talked about before, so remember that if I have something being squared and I square root it, it just becomes the thing inside. So even if it's, something yucky like x minus 7 being squared, it just becomes, when you square root it, it just becomes the quantity inside itself. And even if I put a happy face being squared and I square root it, then I just get the happy face itself. So it doesn't matter whether the thing inside the radicand is simple, messy, or just symbols, it just becomes the radicand itself. Is everyone okay with that? All right, and the square root of 50, what is the square root of 50?
So 5 over 2.
Right, 5 root 2. Right, because remember, square root of 50, you could rewrite this as square root of 25 times square root of 2. So square root of 25 becomes 5, and square root of 2 is just 2. What am I missing?
Making the x by itself.
Right, you gotta get the x by itself, good. But before that, what am I supposed to put right here?
Oh, the
Plus or minus.
Excellent, plus or minus. I always need a plus or minus. So that being said, I heard you guys also mention that we need to solve for x, and we need the x by itself. So to get the x by itself, I'm gonna have x is equal to, I'm gonna add 7 to the other side. So when I add 7 to the other side, I have 7 plus or minus 5 root 2. And that's because I added it to the other side. Oops. Is everyone okay with that step? So how you write this out then, and please be careful. Oh, let me just say this. How you write this out then is that there's 2 answers. The first answer is x is equal to 7 plus 5 root 2. And the second answer is x equals 7 minus 5 root 2. And those are your 2 answers. And again, if you wrote it on, with another teacher, this is totally acceptable. But on Alex, they want you to write it out in 2 ways.
I have a question.
Yes, go ahead.
So for like on the test or like on the quizzes, you want us to write it out both ways?
Because you take their tests or the quiz on Alex, they'll want you to write it out like this.
Okay.
But when you're writing out your work that you turn into me, you could just leave it like this.
Okay.
Yeah. So when you write it out on work, this is just a shorthand way of saying this, but Alex doesn't have that shortcut, so you just have to write it out.
Okay.
Okay, and another thing I really want you guys to be careful of is I've seen students do this. They think they see 7 plus 5, and then they write this as 12 root 2 as the answer. Why is that incorrect?
Because 5 square root 2 is by itself. It's not just 5.
Good. Right. 5 root 2 is by itself, right? Or 5 root 2 is its own animal, its own term, and 7 is its own term. Are these the same animals? Can you add these two?
No.
No, right? So they're 2 different animals or 2 different terms that you cannot combine. So that's why this is not 12 root 2, and this is not 2 root 2. I see a lot of students see 7 minus 5, and then I get 2, and then I put a square root 2. No, right? This is one term, and this is another term. And we learned from the last chapter that to add or subtract terms, they have to have the same radicand. And this is just a 7, and this is root 2, so you can't add those. Is everyone okay with that? Any questions? All right, let me give you guys an opportunity now to do a problem similar to this that's actually not on your example you try. So something similar to this would be, how about x plus 10 quantity squared minus 18 is equal to 0. So go ahead and write that down, and I'm going to give you guys a few minutes to go ahead and work on that. All right, so any volunteers would like to walk me through what to do with this problem? And it's okay if you make a mistake, that's what this time is for. Otherwise I'll just pick on someone.
I don't know if it's correct,
Mm-hmm.
but I got x equals -10 plus or minus 3 radical 2.
Okay, I'm sorry, who is this speaking?
Alexis.
Alexis, x equals to -10 plus or minus 3 root 2. Do you guys agree? People aren't sure.
Yes.
Yes, okay. So Alexis, can you explain to me what you did, and I'll just write it out as you're explaining?
Okay, I may be bad at explaining this one, but I'm gonna try.
Okay, I'll write it out as you're explaining.
Okay, so first thing is I rewrote it into x plus 10 squared equals positive 18.
Okay, great.
And
so
then I of course I squared them, and x plus 10 squared is of course x plus 10, and then 18 squared is 3 squared, 2 squared, sorry. And then when rewriting this equation, you're gonna get x equals -10, because if we're to isolate.
Slow you down 1 second, Alexis. Does anyone have questions with this? She said x plus 10 because she square root both sides, and then square root of 18 became 3 root 2. Does anyone have any questions with that?
I have a question.
Yes.
This is Paul.
Hi, Paul.
So I'm still kind of a little confused on how you make 18 a radical through that process.
So to
I
separate
can see
it,
how you square the 8. I can see how you square the left side and take away the radical. I don't understand making 18 a radical because it's not originally a radical. How do you do that?
well, it's not going to be a perfect square like most other ones. So I basically do the tree trunk method like always, and it's going to be 2 divided by 6, which is, what was it? And then, or I get 2, and then you're going to get, you divide 2 out of 18 is going to get 6. Then you get 2 again and 3.
You get 9. Yeah.
Yeah, and so you so you are going to get, oh, did I mess up?
18 divided by 2 is 9. I think you said 6. You meant 9.
Oh, yeah. Thank you. I thought I did something wrong right now. And then 3 times 3. Thank you. And so we get 2 3s and a singular 2. And so that's how I get, 3 and square root of 2. So that's how I have that particular radical.
Is that okay, Paul? Are you asking how you get square root of 18 to become 3 root 2?
No, I understand. I do understand that part. It's the step just above it. I'm just confused at how you, okay, so I see we added 18 to both sides to eliminate the left side. I guess I'm just confused on how 18 turned from a whole number into a radical.
Oh, good question. That's because whatever you do one side, you do to the other side.
Okay.
So since
Okay.
we square root this side, we have to square root the other side.
Okay, okay, thank you.
Okay. So that's a part of the square root method here. So when you start off with something squared equal to a number, to get rid of that squared, we square root both sides. So when we square root both sides, we have to do that to the other side as well.
Okay, thank you.
Good question. Yeah, it's always a good question of asking why. Why does that happen, right? So why does it become a square root? It's because we square root the other side. And real quick, what is Alexis missing right here?
Oh, it's a plus or, plus or minus.
Perfect. Always write plus or minus. Okay. Is everyone okay up to this point?
Yes.
All right. Great questions. Go ahead, Alexis. Go ahead and finish it.
Okay, and then I subtract 10 to the other side to isolate x. So we can get x equals negative 10 plus or minus 3 to radical 2.
Perfect. And if you were to write this on Alex, type it out, how would you write it then, Alexis?
I would instead write it x equals negative x plus 3 radical positive, 3 radical 2, and x equals negative 10 minus 3 radical 2.
Perfect. Perfect. Thank you, Alexis. Nice job.
Thank you.
Any questions for what Alexis did? All right, so let's move forward. Let's look at now, so that was a square root method. So the square root method was questions 1 to 3. And now we're going to go into what we call completing the square method. So, sorry. Completing the square method I feel like I'm on a doc cam. All right. So in completing the square method, let's talk about what does it mean to complete the squared. So let's look at example number 4 on our worksheet. We have w squared plus 6w, and this is plus blank. So here we're just practicing what is completing the squared. So here, what completing the squared is that we are going to take the middle term. We're going to take that number in the middle, I'm sorry, not the middle term, but the middle coefficient, the 6, and we are going to divide it by 2. And you might be wondering why, and I'll explain the why after a second, but I just want to do the example first. So we're going to take the middle term, we're going to divide it by 2, and then we're going to square the whole thing. So 6 divided by 2 gives me 3, and then 3 squared gives me 9. So that magical number, I call it magical number, is going to be put here. And that's what it means to complete the square. You put a number, an appropriate number in that blank. And the reason why, so why are we doing this, right? The reason why we do this is because now we're going to factor that. So if I factor the above, I have w squared plus 6w plus 9. Let's go ahead and try factoring it. I notice there's 3 terms, so I'm going to do Xbox method. So when I do Xbox method, I'm going to say, okay, w times w gives me w squared. What 2 things multiply to give me 9? 3 and 3. I cross multiply. I get 3w plus 3w. Does that give me 6w? It sure does. So these numbers work. So I'm going to box it. Again, I'm going through factoring really fast. I'm going to box it. So when I factor that, that now becomes w plus 3 times w plus 3. And what do you know? W plus 3 times w plus 3, you could rewrite it as w plus 3 squared. So that's what completing the square does. It takes a polynomial, you add a magical number next to it from completing the square, which is take the middle term, divide it by 2, and square it. That magical number 9, when you factor the polynomial with that magical number 9, you will always, always, always factor it in a way where you get something being squared. And that's why they call it completing the square.
What if the middle number is odd, like a 7?
Oh, that's a great question. So if the middle number was odd, so here, another example. What if we said w squared plus 7w plus blank? Go ahead and try that. Complete the square. So remember, take the middle number, divide it by 2, and square it. What do you get?
Three and a half.
You get 3.5, and then you
Yep.
square that. What happens when you square that?
12.25.
I don't have a calculator in front of me, but I know in terms of fractions, 49 over 4, right?
Yeah.
Right. So you're going to get 49 over 4, and then you're going to ask yourself, how in the world am I going to factor that? Right? So that's where I would not use this method to solve this quadratic equation. I would actually use another method if it was something like this. So it doesn't work for all things, but it is possible. So, I mean, if I set this equal to 0, right? If this was an equation, how do I get rid of a fraction? If you have a fraction in an equation, how do you get rid of a fraction?
You multiply times the denominator.
Right. You multiply it by the lowest common denominator. So I would get 4w squared, because I multiply everything by 4, plus 28w plus 49 is equal to 0. And I'm going to try to see if I can factor that. However, in this ALEX worksheet and in ALEX itself, you won't get these situations. You'll always get a situation where you get a nice, pretty number. So in these cases, I would say, don't worry about these questions, because you won't get these scenarios in ALEX. But I do want to show you, if you did get a scenario like that, what you do is you get rid of the fraction by multiplying by the LCD, and then you factor it, right? In case you did. All right, so let's go ahead and take a look at, so on question 4, your answer is just 9, right? Because you're just practicing doing that. But what is the point of that? Let's look at question number 5. So now we're going to do this in the context of a problem of solving a quadratic equation. So here in question 5, I have x squared minus 4x minus 1 is equal to 0. And then if you look at the problem, it says write down the form and then write down its solution. So here, first of all, let's try to factor it. Because personally for me, I always try to factor before I do anything, because that's the easiest thing. Let's try to factor it. X squared. I notice this is an X box, so I'm going to try doing X box. So I'm going to say, okay, x squared minus 4x minus 1 equals 0. Two things that multiply to give me x squared are x and x. Two things that multiply to give me 1 is just 1 and 1. One of them is going to be negative, right? I'm not sure which one yet, but when I cross multiply, I get 1x and 1x. Can I add or subtract that to give me a negative 4x? No, right? I can't add or subtract a 1 and a 1 to give me a negative 4. Even though I put negatives here, it will never, ever give me negative 4. So in this case, I say factoring does not work. And then I feel sad, because that means I have to do more work. So factoring is always my go-to, but since it doesn't work, I'm going to now use completing the square method. So the completing the square method says that, first of all, I want to write it in the form of x squared plus 8x plus blank is equal to a number. So completing a square method, step 1, you want to write it in this form. So you want x squared plus ax, a is some number, plus blank is equal to a number on the right side. So in this problem here, I have x squared minus 4x minus 1 is equal to 0. I know that I cannot factor that. So I want to write it into a form where I can factor it. So what I'm going to do is I'm going to do step 1, x squared minus 4x. I'm going to add 1 to the other side, and I'm going to have plus blank. Does anyone have any questions with this first step? This first step is me just trying to get it into the form so that I can complete the square. So the form is that x squared minus 4x plus blank is equal to a number, this form here. And the reason why I have it in that form is because of step 2. And in step 2, I'm going to complete the square. Complete the square. Fill in the blank. And what I do with that is I take that middle coefficient, a, I divide it by 2, and I square it. And that's going to give me a magical number. And that magical number, I'm going to plug that magical number into that blank. So x squared plus ax plus, in that blank, I'm going to put that magical number. But because this is an equation, so remember I have a number on this side. Because this is an equation, whatever I do one side, I must do to the other side. So if I added a magical number on the left side, I have to add a magical number on the right side as well. So that's step 2. So step 2 is completing a square by adding a magical number in here. And how do you get that magical number? You take the middle term, divide it by 2 and square it. And then you add that magical number on both sides of the equation. So in this problem here, I have x squared minus 4x plus blank is equal to 1. So I need to find out what that magical number is. So I'm going to take the negative 4. I'm going to divide it by 2, and I'm going to square it. What do I get?
You get a 4?
You get a 4. There's my magical number. So that magical number, I'm going to put plus 4. I'm going to put plus 4 here. Because whatever you do one side, you must do to the other side. So step 3 is, and you're like, well, why did I do that? Well, the reason why we did that is so that we can factor. Because remember, the original problem, we couldn't factor it, right? With a negative 1, I could not factor this problem. But now that I have a plus 4, I should be able to factor it now. So now when I try to factor this, I get x squared minus 4x plus 4 is equal to 1 plus 4 is 5, right? That's 5. So let's try to factor this left side. 2 things that give me x squared, x and x. 2 things that give me 4, 2 and 2. If I cross multiply, I get 2x and 2x. Can I get a negative 4x? I sure can if I make them both a negative. If I make them both a negative, I get a negative 4x. So therefore, I need to put a negative here and a negative here. And notice that a negative 2 times a negative 2 will still give me a positive 4. So it still works. So here's my x box. So I'm going to say factor. We're always going to be using Xboxing. So after you Xbox, you're going to get x minus 2 times x minus 2 is equal to 5. And I could rewrite that as x minus 2 squared is equal to 5. And that was the point of completing the squared. Completing the squared helped me to factor this. And when I factor it, it'll always become something being squared, a quantity being squared. And that's why it's called completing the square. Any questions so far? All right, and remember, the point of this problem is to solve for x, right? So we're like, okay, now what do we do? That was step 3. Well, step 4. Step 4, so we're not done yet, right? So step 4 here is now, well, guess what? I have a quantity squared is equal to a number. Guess what I'm going to do next?
Square.
Right. We're going to use the square root method, square root property. So that property that you just learned a couple of minutes ago, now we're going to do it because we have it in the form quantity squared is equal to a number. So what do you know? Quantity squared is equal to a number. I heard you guys say to square root it, right? So we're going to square root both sides. So when we square root both sides, I have to put a plus or minus on that side. So when you square root both sides, what does the left become?
X minus 2
Great.
equals 25.
Not quite, because we're
sorry, equals, what was it, plus or minus? Wait, so we're square rooting it, not squaring it, so that would just be 5, right?
Square root of 5, right? Yep, we're square rooting the square root of 5. A square root of 5, we can't simplify that, right? If I could simplify that, I would, but I just leave it as is. So our final answer then is we're going to add 2 on both sides, so we get 2 plus or minus square root of 5. Or you could write it on Alex, x is equal to 2 plus root 5, and x is equal to 2 minus root 5. Whew, right? That's why I prefer factoring, but when factoring doesn't work, you could always turn to this method. I know that was a lot. Does anyone have any questions on this problem? All right, if you don't have questions on this problem, I'm gonna have you guys do another problem. So I'd like you guys to try. You try. I'd like you to try this problem here. X squared plus 14x plus 144 is equal to 0. And again, the first thing I'd always do is I try factoring, and I'll just show you guys again, factoring doesn't work, right? If I try to factor 144, 12 times 12 will give me 144. If I cross multiply, I get 12x and 12x. That will not give me 14x. So here, factoring doesn't work. So I just want to throw out that case just to emphasize that when factoring doesn't work, you always want to try that first. But if it doesn't work, then go ahead and do the completing the square method. All right, let me give you guys a few moments to do that. And as you're working, if you guys have any questions, feel free to speak up and ask questions, and Garrett will be there to, or myself will be there to help answer any questions. All righty, let's go ahead and get started. I'm just gonna call on people. And again, if I call on you, you don't know how to do it, that's A-okay. We'll walk you through it. How about Noemie? Are you there? Noemie? If not, how about Melissa?
I'm not sure how to do it.
Okay. Well, let's walk you through it. Step one, let's go back to step one. What should we do first?
We move the 144 to the other side so we can have that blank space.
Great. So we move the 144 to the other side. So I have x squared plus 14x plus blank is equal to, and if we move it to the other side, what does it become?
Negative 144.
Great, negative 144. That's the first step. Is anyone okay with that?
Mm-hmm.
Melissa, you okay with that step?
Yeah.
All right. Step two. What is step two? What happens after you move it over? What do we do in that blank?
To take the middle number, which is 14, and divide by 2.
Okay, take the middle number, divide by 2.
And then you have to square it.
Okay, and then you square that. So what do you end up getting?
49.
49. The magical number. What do we do with that number 49?
Add it to both sides, so in the blank spot, and then the negative 144.
Good. So we add it to both sides. Right? Those are the two things that we added. Is everyone okay with that? Any questions? All good in the hood? All right, step three. What do we do after that?
You, I think you can start factoring.
Good. So now let's try factoring this. So if you factor this, x squared plus 14x plus 49, what do we get when we factor that?
X plus 7.
X plus 7 times x plus 7, right? Or in other words, x plus 7 squared. And what does the right side become?
I was a little bit confused about this part because when I did the negative 144 plus 49, I got negative 95. And then after that, you square root both sides. But then I got confused with the plus or minus signs, and then the negative 95.
Right.
Kind of stopped there.
Yeah, I did too, because I noticed that you can't really square negative 95.
Mm-hmm.
And then, so it remains negative 95. So I don't know if we still put plus or minus, if that negative still exists within the actual radical.
Can you break it down like 95 times negative 1?
Wait, what?
Like radical 95 times radical negative 1, and then you make the I, something like that, no?
Is that something that we can do in this particular equation?
X squared. Oh, you know what? I noticed I wrote down the wrong problem. It should have been a 44 instead of a 144. And that's why we're getting a problem with it getting an I, having a complex number in it. So I see what I did.
Well, you guys are on the right track with what you're talking about.
Right. You guys are totally on the right track. So let's keep going down the track that you guys are going with, right? So it was supposed to be a positive. I mean, it's supposed to be a negative 44, not negative 144. I don't know why I saw 1 for some reason, but I'm going to keep going down the track that you guys are going. And I love the conversations that you guys are having. So after we do that, then step 4 is that you did the square root method, right? Mm-hmm. So the square root method, you square root at both sides. So when you square root both sides, plus or minus square root of negative 95, right? So when you square root both sides, you end up getting x plus 7 on the left, which is a-okay, right? Is equal to plus or minus, yeah, since you have a negative, 95, you're going to have a complex number here. So we can split up negative 95 as the square root of 95 times the square root of negative 1. So you know that this is going to have an I. What's square root of 95? Can we simplify that?
No, because I was only able to do 19 times 5 is 95, and you can't really square anything from 19.
Right. So, right, 19 times 5 gives us 95. There's nothing that can be squared. So that is the simplest form. So therefore, this is plus or minus I square root of 95. I just put the I in the front, right? Yet x plus 7 is equal to plus or minus I square root of 95. Is everyone okay with that?
Yeah.
So yeah, so as you can see, we're dealing with complex numbers now, right? And then therefore, what is our answer then?
It's going to be x equals negative 7 plus or minus I square root of 95.
Exactly. Exactly. Oops, sorry. Nice work. Very nice work. Does anyone have questions on any of this at all? A question like this is combining a lot of our knowledge. We learned completing the square. We had to apply square root method. We had to apply factoring. We had to apply the square root method. And then we had to apply complex numbers, right? It's talk about like everything, like adding all up to get to this problem, right? So just letting you know, on Alex, you won't get a problem like this where you end up getting an I as an answer because I actually wrote the problem wrong. It should have just been 44, and it was 44, then you wouldn't have had an I in the end. But if it was this problem, you guys did it totally correctly. But just letting you know, on Alex, it won't be that hard. All right, so let me give us a chance to actually just take a quick, if you guys don't mind, just a quick 5-minute break. So 11:51, come on back. Alrighty, welcome back everyone. This is my son Sawyer. You wanna say hi? Hi. He wanted to see what class is like for mommy. All right, so at this time, I'm going to have the group presentations. So I'm going to, hold on, buddy. Screen share. Who wants to go first? There's 2 group 5s. Who wants to go first?
I can go first.
Who's I?
Kaela.
Kaela. Oh, Kaela, you want to do your student spotlight, right? Is that what you're saying?
Yeah, I'm also in group 5. I did my group presentation separately only because I had trouble like getting a hold of like my classmates. So okay. I just did mine. Yeah, I sent it to you on the Canvas email.
Oh, okay. Then let me go ahead.
Why do you keep doing that? Mommy, why do you keep doing that?
Okay, go ahead. Sorry.
Okay, so for problem number 1, it's a matter of order of operations. So you first have to do what's in the brackets. So you start with the parentheses since that's what goes first. And then you divide it by 2 minus 1. So then you divide 10 and 2 and you get 5 minus 1 in the bracket. And then you multiply that after you subtract it and you get 24. Then for number 2, it's fractions. It looks a little weird because it wouldn't type the fractions normally, but it's 5 over 9 divided by 3 over 10. So since it's dividing fractions, oh yeah, 8, sorry. So you flip it because that's what you do when you divide fractions, and so you get 5 over 8 divided by 10 over 3.
Mhm.
And then divide 8 and 10 by 2, then multiply to get 25 over 12. And then for number 3, it's 7 over 6 divided by 3. So then you would put a 1 under the 3 so they could both be fractions, and then you multiply them. And when you do that, you can simplify it by dividing the 6 and the 3 by 3, and then you would multiply to get 7 over 2. And then for 4, it's 1/6 to the 4th power. I couldn't type it like with the 4 up, so I just did it like that. So when you multiply it 4 times, you get 1 over 81. And then for number 5, it's 5 over 9 times 6. So similar to that other problem, you put a 1 under the 6, and then you would get 30 over 9. And you can simplify that by dividing the top and bottom by 3, and then you would get 10 over 3. And then Ruby's going to do 6 to 10.
Hi, my name is Ruby Puentes, and we're going to find the reciprocal on 6. For 4, all you do is add a 1 to the numerator to get 1 over 4. And then
Sorry, go ahead.
It's okay. And then to get the reciprocal of 5 over 9, you just switch the numerator and the denominator, and you get 9 over 5. For 7, you reduce the fraction. Oh, well, you add the top, so you get 8 over 12. And then you reduce the fraction, and you get 4. No, yeah, you get 4, and then you get 2/3. And then for 8, you multiply the numerators and get 40, and then you multiply the denominators and get 396. Then you reduce the fraction to 10 over 99. And then for number 9, you just add all the sides, and you get the perimeter, which is 20 centimeters. And then for 10, you use the formula area of rectangle equals length times width, and you get 2,418 inches squared. And then for the perimeter, it's the same as 9. You just you add all the sides, and you get 202 inches. And that's it.
Awesome. Any questions for Sophia or Ruby?
Why does it say that's all?
That's all, folks. It's like a cartoon. Any questions?
Thank you.
Questions or comments? Great. Thank you for the review. And I really liked how you guys remembered, or you guys talked about inches and inches squared for area and perimeter. People sometimes forget that. So really great examples. Did it help you guys to learn or review the material by doing this?
Yeah, I had to review some stuff.
Yeah, I feel like it always helps to do littler things like that because you always need them later on in other lessons. So the review kind of helped me remember some things.
Mm-hmm.
Good, good. Yeah, sometimes like when we actually teach something or prepare something, we actually learn it even more, right?
Mm-hmm.
So that's really great. Great job, ladies. I think there was another group that was up. 1 second. Come on, buddy. The other group was, who was it? Kaela?
Yes.
Okay, I see your group presentation. Sorry, Charlie. All right, Kaela, you're up.
Okay, so for my group presentation, I chose to present it on Chapter 6A because we just recently finished our Chapter 6A homework. So I thought it would be good review for everyone. So moving on to the next slide. So what is a radical? So a radical is defined as any expression containing a radical. It can also be used to describe a square root, a cube root, a fourth root, or higher. And so I added a little picture on the side that like shows what a radical is. Like if I was teaching like a person who didn't know what a radical looked like at all. Moving on to the next slide. I put what are the parts to a radical. So when dealing with radicals, there are a few different parts. On the picture on the side, it shows you as well. You have the coefficient of the radical, the index, the radical, the radicand, and then the radical symbol. And it just like points exactly to where it was. Moving on. Examples of a radical expression. So I just gave 3 examples based off of the Alex homework that I thought were useful. And these are kind of like the basic radical expressions of if you were doing a radical. So I did 28 equals 4 and then 7, because if you were to break 28 down, 4 times 7 is 28. And then you equal it and you get 2 on the outside and then radical 7. Moving on to the second one, you have 192 equals 64 and 3. And then that equals 3, radical 3. And then the next one is similar but a little different. You have the cube root and then the radical 3, 43. It equals 3 raised to the 7. And then if you just kind of want to like simplify that more, it would just be 7 times 7 times 7. Moving on. I said try for yourself, so I just gave 3 problems like for the class to try. It's just like review. It helped me as well when I was going back in my notes. So I just have 3 problems for everyone to try, so you can just try it yourself, and then once you're done, you can just shout out the answer.
So feel free, anyone, to shout out the answer.
Would number 1 be 5 square root of 3?
Yes, that is correct.
Would number 2 be 5 square root of 5?
Yes, that is also correct.
The last one's a little bit harder.
Would it be 18i square root of 3? No, of 6?
I think for my answer, I got -6 raised to the 3rd. I'm not sure. I got -6 times -6 times -6, which I think would be -216 raised to the 3rd.
Oh, I see. I think your number 3 is a cube root of -216, right?
Right.
Okay, it looks like it's 3 times square root of -216.
Oh, my bad.
Okay, and that's
I
why
was
Anthony thought it was imaginary.
Oh yeah, I'm sorry about that. On the PowerPoint, I tried to use like lines to do the square root, so it was kind of difficult. So I tried to do it to like the best of my ability. But yeah, it's 3 cubed radical -216. So in that case, it would be negative parentheses -6 raised to the 3rd.
Yeah, I got it.
Okay, cool.
Great.
And then moving on, I just did my work step by step, just in case like somebody had like difficulty doing it. So I just like explained my work step by step. So the 75, if you break that down, you're going to get the 25 and the 3, and that equals 5 radical 3, which one of our classmates said. Number 2 is 125, and that equals 25, and radical 25 and radical 5, and that equals 5 radical 5, which someone also said. And then 3 is the cube root of negative 216, and that equals negative 6 raised to the third. And then if you wanted to break that down more, it would be negative 6 times negative 6 times negative 6.
So the answer for number 3 would just be negative 6.
Right.
Yeah. So negative, I think you just forgot that part here.
And then that's the end of my presentation.
Awesome. Any comments or questions for Kaela? Great. That's a great review of radicals. Man, I feel like I should keep all of these slides so that I could use them for my future lectures for students. These are
I
great.
just added pictures because I know pictures it kind of makes the PowerPoints a little more interesting, because PowerPoints can tend to be like a little boring.
Awesome. Right. And I know a lot of you guys are trying to write down like mathematical symbols on your PowerPoint. There is something on the PowerPoint that says an equation editor or something like that, where you could actually write and type out mathematical equations so that you don't have to like draw lines like I know you did, Kaela. So just letting you know, the more that you like mess around with PowerPoint, you'll find that there's actually a lot of things in there that can help make your life easier, especially writing math symbols.
Okay, good to know. Thank you.
Yep, excellent work. And I think was there another group that was ready to go?
Yeah, Stefanie.
Stefanie, and where did you send it to me again?
Canvas.
On Canvas, okay. Oops, let me. All right, so Stefanie and Noemie, you guys are up.
Factoring trinomials. Factoring trinomials means finding two binomials that when multiplied together produce a given trinomial. Always look for GCF before factoring, which is the bottom part, x squared plus bx plus c, that's the trinomial form. And these are some steps for the X box method that we're going to use for this problem. Write in standard form, high exponent to the low exponent. Look at first and third term. Write out the factors of each. Cross multiply. Do these terms add or subtract to give you the second term? If not, then try a different order or a different number. Once you get the answer, rebox the first and the second U. And this is one of my examples. I got x squared plus 5x plus 6. We need to find factors of 6 that add up to 5. Since 6 can be written as the product of 2 and 3, and 2 plus 3 equals 5, we can use the number 2 and 3 factors. I asked myself to be add or subtract, so I add and I got 5x, which I got the second term. And in this next step, we cross multiplied. And then we go straight ahead, which I got x plus 2 and x plus 3, and that will be my final answer. And then it's now your turn to try.
The first one was x minus 7 squared.
Yes. Or you could do x minus 7 and x minus 7.
Yeah. The second one is x minus 9 and x plus 4. Or x plus 9 and x minus 4, sorry.
Yeah, that one's right.
So now it's factoring polynomials, and when you're factoring by grouping is when you create a smaller groups within the problem, and it is done by grouping the first two terms together and the last two terms together. Then you factor out by using the greatest common factor for the two groups, and the grouping form is x to the power x cubed plus x squared plus bx plus c. And here's an example. Well, it's AB plus AC plus DB plus DC. Then you group them together. So you separate them in two groups, and it's AB plus AC and DB plus DC. Then step 3 is just factor the common term in each group. And the common term for the first group is A, and for the second is D. So you end up having A plus D and B plus C. And this is the first example. So it's 3x squared plus 6x plus 4x plus 8. Then you separate the two terms into two groups, and you find the greatest common factor. And for the first one is 3x, and for the second is 4. And just to make sure, you could also distribute to make sure you got, so you could get the answer that's on top, which you do. And the final answer is x plus 2, 3x plus 4. One parentheses for each one. Now it's your turn.
I liked how you wrote down the 3 and the 2.
I know, I don't know how to do the on top with the
script, yeah. All right, just for the sake of time, I'm just going to keep moving forward, if you don't mind.
And that's your final answer for the first problem and the second problem.
Do you guys have questions on that? All right, good job on grouping questions. All righty, any questions for this group? Questions or comments for Stefanie or Noemie? All right, I love how you guys are reviewing so much of the math material. For the groups that still have things to do in the future, again, you could review things. You could talk about any current issues that you want to share about how it relates to math. You can do that as well. And I know one's done it yet, but I'm waiting for someone to do a coronavirus math presentation. I think that'll be really interesting to make graphs or show information about how they're getting the mortality rate or this, and that. It kind of makes it really interesting. So there's a lot of application of math in what's going on in the world right now. All right, without further ado, we're going to continue on with our lesson. We're going to cover one more section since we only have about 12 minutes left. We don't have time for student spotlights today, so I just want to make sure we get to the last topic. All right, so in the last section now, we are going to go over the last method, which is the quadratic formula. So far we've learned how to do the square root method. We've learned how to complete the square. And the last one is the quadratic formula. So the quadratic formula is actually, I think, easier than the completing the square method. I thought completing the square method was the hardest. But the quadratic formula is going to be a formula that you use just to answer problems. So here I'm going to look at example number 6. And that says 9x squared plus 5x is equal to 1. So in this problem here, we cannot factor. So just letting you guys know, if you factor it, it's not going to work. You're not going to get a pretty answer, or you can't factor it. However, we can complete the square. So when we complete the square, we end up getting a certain answer. And every time we complete the square for these types of problems, we find out that there's a pattern, or there's a formula that fits into solving these problems using completing the square. So without proving it, and again, I can't prove the quadratic formula. We get the quadratic formula from completing the square. But in the end, the formula is this. If we want to solve for x, the answer is going to be, does anyone know it by any chance? Or does anyone know the quadratic formula? It starts with a negative b.
Wouldn't it be, yeah, plus or minus and the square root of, isn't it like a times 2a? 2a? Or
Almost. Yeah, you're kind of on the right track. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is the big kahuna formula that you need to memorize for this. And I memorized it when I was in high school and college, and I memorized it to this day because I use it so often. So negative b plus or minus square root of b squared minus 4ac all over 2a. And you might be wondering, what are a, b's, and c's? What are these a, b's, and c's here? So this is when you're given, so this is when we say that a quadratic equation is a standard form. Standard form is when you have a quadratic equation that's in the form of ax squared plus bx plus c is equal to 0. So when you have it in standard form, then the coefficient of x squared is going to be your a, and that's what a is. The coefficient of your x is going to be b, and that's what b is. And then c is the constant. So c stands for constant. So that's what c is. And then instead of completing the square, which takes a long time, as you can see, there's a shortcut, and that shortcut is doing quadratic formula. So you plug it into this equation, and you end up getting an answer for x without completing the square. But really, this formula was derived from completing the square, which I'm not going to spend time in class showing you the proof, but if you're interested, you can always look it up or ask me and I can show you. But I'm going to be more concerned of how do you solve this problem using the completing the square. So the first thing you do, step 1, is you want to set the quadratic equation in standard form. So you want to set it up so that it is in a form so that we can use it. So here it has to equal to 0. So here, this problem, I'm going to set this equation equal to 0. So I'm going to subtract 1 on both sides. I get 9x squared plus 5x minus 1 is equal to 0. And it's in the form where x squared is first, then x, then a constant. So by doing so, I can identify the a, b, and c. So in this problem, my a is going to be 9. My b is going to be 5. And my c is going to be -1. So now that I have my A, B's, and C's, does anyone have questions on that? So step 2 is going to be, I'm going to plug in A, B, and C into the quadratic formula. And this is a quadratic formula here. So when I plug it in, I have x is equal to negative b, so that's going to be negative 5, plus or minus the square root of b squared, so 5 times 5 gives me 25, minus 4 times a times c, so 4 times 9 times negative 1. That's 4 times a times c, all over 2 times a, and a is 9. So it's just having to be really careful plugging things in, remembering your negative signs, this and that. So it's just more of like plugging things in that makes it a little bit, that we just have to be careful of. So here in this problem, remember the orders of operations. I see a lot of students say 25 minus 4 and they get 21. So no, that's not correct, because you're supposed to do the order of operations, and the order of operations says that you want to, when you look under the radical signs, you do not subtract, but you multiply first. Right? So you multiply first when you're doing the order of operations in here. So 4 times 9 times negative 1 will give me negative 36. 4 times 9 times negative 1 is negative 36. So that being said, when I do this problem here, sorry, let me. So when I do this, I'm going to get, trying to center this. X is equal to negative 5 plus or minus. In the radical, I have 25 minus a negative 36, so that becomes 25 plus 36, all over 2 times 9 is 18. And 25 plus 36 then gives me 61. So that gives me negative 5 plus or minus the square root of 61 all over 18. So imagine we tried factoring. Do you think we'll ever get this answers of factoring? No, right? So using the quadratic formula really helps. And then I asked myself, well, can I simplify square root of 61? And the answer is no. 61 can't be simplified, so therefore that becomes your final answer. Does anyone have any questions on the quadratic formula?
For what questions would we be able to use this for? Like from?
Great. So looking at your work, can you see the worksheet? Yeah. So on your Alex worksheet that I gave you, that's question 6. It says use a quadratic formula. Oh, and actually question 6 is round your answer to the nearest hundredth. So when you round your answer to the nearest hundredth, that just means that you need to plug that into your calculator and then it's rounded to the nearest 2 decimals. So when it says rounding something, that means plug it into your calculator to get the decimal answer. And if you guys, as you guys are doing that, if you have problems getting the right answer with your calculator, feel free to message me or find Garrett on Discord, and he could help you with your calculator work to figure out how to plug that into your calculator. Question number 7 says find all complex solutions. So this means to also do quadratic formula, but you're going to have an imaginary number as a result. Because if you guys saw that problem that we just did, we have a radical in our answer. If you have a negative inside the radical, then that means you're going to have a complex answer. So you might have to deal with i's, like imaginary numbers. Okay, so that's up to number 7. Number 8 and 9, all the way to number 19. I haven't had a chance to lecture on that. I think what I'll do is I'll put number 8 and 9 on YouTube, so you guys can see what 8 and 9 are like. And then for Sunday, all that's due up to Sunday is up to question 9. And then questions 10 to 19, I'll cover that on Monday. So you guys are responsible for everything up to topic 1 through 9, and 8 and 9, I will do that on YouTube. Does anyone have any questions?
Will you post the YouTube video on Canvas also?
Yeah, I actually probably already made YouTube videos on these types of things, so I'll go ahead and send that to you guys because I think it's already done.
Okay.
Great. Does anyone else have any other questions on anything?
No.
All right, great job for those who presented and great job for everyone that participated. Remember, the homework is due tomorrow for radicals. The quiz is tomorrow for radicals. And then after that, you can start working on your quadratics, and that'll be due on Sunday. And if you guys have any questions at all, you guys know you guys can always reach me. Give me up to 24 hours to respond just in case. I try to do it sooner. Again, Garrett will be available until Thursday until 4 o'clock, so you can reach him as well. All right, that being said, I'll keep in touch with you guys, and I will see you guys on Monday at 1 p.m.
Thank you.
All right, thank you guys. Take
Bye,
care.
Professor.
Bye, take care.
I actually have a question.